Hello everybody, today we're going to talk about our first conic section, which is parabolas. Okay, so I wanted to first review what conic sections are and how we achieve this specific conic section, a parabola. So remember, a conic section are the graphs that are achieved when you have a plane intersecting kind of like two cones stacked on top of each other. That's why they're called conic sections. Okay, and the way you orient that plane, whether it's vertical or tilted or horizontal or straight up and down, um, and where that plane is located will result in different graphs in the intersection of that plane and those cones. Okay, so the first one, like I said, we're talking about our parabolas, and parabolas are achieved when that cone is, or I'm sorry, when the plane is slanted a little bit and intersects only one of those cones, and it only intersects kind of like one half. See how, like an ellipse, the plane is slanted, but it goes all the way through the cone? A parabola, the plane is slanted a bit and only goes through a part of this cone. Now, this cone will extend up forever and extend down forever on this end, so the parabola is going to go up forever, but the plane doesn't go all the way through the cone like it does here with an ellipse. So the graph we get is this sort of U shape that I'm sure you're familiar with, but we're going to talk about it in the context of a conic section and when it's the intersection of this plane and the cone. So like I mentioned before, you've probably seen parabolas before, worked with them, graphed them, but today we're going to talk about some properties and the real definition of a parabola that you might not be familiar with, okay? So a parabola, the official definition of a parabola is the set of all points in a plane that are the same distance from a fixed line and some fixed point not on the line. So first we need to talk about what fixed means. In this context, fixed means that they're staying in one spot, okay? So the point and the line are not going to move, and the parabola, all of the points on the parabola, when you go up and down on either side, all of those points are the exact same distance from that fixed point and that fixed line. Now, what are those points and lines called? Well, the fixed point is called the focus of the parabola, okay? So the fixed point is called the focus. And the focus is always going to be inside the parabola, okay? The fixed point is the focus. It's always inside the parabola. The fixed line we call the directrix, and it's always outside of the parabola. Specifically, if it's a standard parabola that's opening up like this, the directrix is always going to be underneath the parabola. Okay, so the focus is the point, always inside the parabola. The directrix is the line, and it's always underneath the parabola. Okay, so every single point on this red parabola right here has the same distance from the directrix to the focus. Okay, now that length is a straight line, okay? It's not like we're saying if this is our point, we're not saying this distance here to the directrix at the center of this parabola is the same as the distance to the focus. Clearly, that's not the same. But if you go straight down to meet the directrix, or maybe up or left or right, depending on how the parabola is oriented, but in this case, if you go straight down to meet the directrix, this distance here is the same as the distance to the focus, and that is the case for every single part of this parabola. This is just a set of infinitely many points, and all of these points are the same distance from the directrix and the focus. Another thing to consider here with this parabola is that, remember, we have what's called a vertex, and the vertex of the parabola is the point right there in the middle. If it's oriented up, it's the lowest point of your parabola. If it's going down, so if we reflected this parabola and it looked something like this, then your focus would be the highest point, or I'm sorry, your vertex would be the highest point. Okay, so your vertex is the lowest or highest point in a vertical parabola, and it's pretty important here in regards to the focus and the directrix, because since it is in the middle of your parabola, the vertex is going to be, just like every other point on this parabola, the same distance to the focus and to the directrix. But since it is right in the middle, this vertex is actually the midpoint of the focus and this point right here on the directrix. So we can find the vertex if we're given the focus and the directrix by just finding the point that's right in the middle of those two things, because every single point on this parabola is equidistant, okay? But since the vertex is in the middle of the parabola, as is the focus, we can find it even if we don't know anything else about the parabola other than the focus and the directrix. So now we're going to talk a little bit about the equation of a parabola and how we can find the vertex, focus, or directrix. Okay, so the equation we're going to use typically when we're talking about parabolas is this equation right here. We call this vertex form of a parabola. Okay, you may in the past, actually you've probably seen y equals ax squared plus bx plus c. This is called standard form of a parabola, and it's great for solving a parabola when you're using the quadratic formula or you're solving by factoring. But we're going to talk about parabolas in vertex form mainly because it's very nice, very easy to graph a parabola when you see it this way. Okay, so vertex form is y equals a times parentheses x minus h squared plus k. Okay, and this is only for when we have a vertical parabola. I mentioned earlier that we might see some horizontal parabolas, which may be uncharted territory for you, but a vertical parabola is just our standard parabola. It either opens up like this, or it can open down like this. Okay, so that's what the orientation means. It opens up or it opens down. Okay, and the reason this is called vertex form of a parabola is because you can immediately tell where your vertex of this parabola is. Remember, the vertex is the highest point or the lowest point, so it would be either this point right here or this point right there. Okay, and when it's in vertex form, your vertex is just at h comma k, where h is the value inside the parentheses being subtracted after x, and k is the point being added on at the end. Okay, so it's important to note here that the vertex form of the equation is x minus h. Okay, so if it were, let's say, x minus 3 in parentheses squared, then the x-coordinate of your vertex would be positive 3. Okay, because it's minus 3 here, and that's the general vertex form of a parabola, then the minus 3 is going to make the x-coordinate of your vertex positive 3. And similarly, if it were x plus 6 in parentheses squared, well, that's like x minus negative 6, so the x-coordinate of your vertex would now be negative 6. Okay, so it's like the opposite of what's in parentheses. That's going to be the x-coordinate of your vertex when it's a vertical parabola. The y-coordinate of your vertex is k. That's the number added on at the end. Since the general form is just plus k, then we don't have to take the opposite or anything. It's just whatever's being added or subtracted on at the end. Okay, so the nice thing about vertex form is, again, you can immediately figure out where your vertex is, which can then help you find your focus. Remember, the focus is the point inside the parabola. So maybe that's right here or right here. Okay, the focus is just at h comma k plus 1 over 4a. So let's kind of dissect what this is saying right here. Okay, the x-coordinate of your focus is exactly the same as your vertex. And that's because if you look at these rough sketches I have up here, this green point is our focus. Okay, it is directly above or below our vertex. Okay, when something is directly above or below something else in a graph, a coordinate plane, then it's not going any farther left or right. It's got the exact same x value as that other point. Okay, so since this green focus is directly above or directly below here, this vertex, then its x-coordinate is going to be exactly the same as the vertex. Okay, so the x-coordinate of our focus is just h, exactly what our vertex is. However, you can see that this green point is a little above or a little below the vertex, so the y-coordinate is going to be different. So the y-coordinate of our focus is k, right? So that's, imagine here's h comma k, but we're a little bit above or below, and that a little bit above or below that we are is actually 1 over 4 times a. And that a value is the exact same a value we have right here. Okay, so if this a value is really, really big, that would make our parabola skinnier. Okay, so maybe it looks like this. And what that's going to do is actually get your focus closer to the vertex. Okay, so as the parabola gets skinnier, the focus will get closer to the vertex. And that's illustrated here in the coordinate of your focus, because if A is big, then this denominator 4A is going to get really big. Say if A was 10, that would be 1 over 40. Well, 1 over 40 isn't quite that big, okay? But if A is 1, then that would be 1 over 4, and that's obviously bigger than 1 over 40, so it's going to get a little farther away from the vertex. So as A increases, your focus is getting closer and closer to the vertex. As the parabola gets skinnier, your focus is getting closer to the vertex. And conversely, if A were small in the sense that it's the absolute value of A is between 0 and 1, or it's a fraction getting closer and closer to 0. Say A were 1 over 16. Then that would make our parabola fatter, like this. Okay? And if our vertex is right here, our focus as the parabola gets fatter is going to get farther away from the vertex. And again, that would be illustrated here. If our A value were 1 over 16, that would be 1 over 4 times 1 over 16. And 4 times 1 over 16 is just 1 over 4. So that'd be 1 over 1 over 4. And how many times does 1/4 go into 1? That would be 4. So that means our focus is 4 units, in this case above our vertex. Okay, because A was 1 over 16, that makes the denominator smaller, which is going to make this entire value 1 over 4A bigger and move the focus farther away from the vertex. Okay, so a big A value makes the focus closer to the vertex. A small A value will move the focus farther away from the vertex. And again, you can find the coordinates of that focus by figuring out what that 1 over 4A units is, and that's how much above or maybe below our vertex the focus is. Now, why do I say below? Well, because like in this second parabola here, the focus could be underneath this vertex if the parabola opens down, okay? And you probably know what needs to happen with this A value for the parabola to open down. It has to be negative, okay? So if this A value right here became negative, then that would flip the parabola upside down and it's going to start opening down. And that's also going to be reflected in the coordinates of our focus, because if A were negative, say it's just -1, then we have 1 over 4 times -1, which is just -1/4, which then makes this K minus 1/4, which is going to move our focus below the vertex, okay? And just like a parabola that opens up, okay, if A is getting farther away from 0, so maybe it's -10, that's going to make the parabola skinnier but open down, and it's going to move the focus closer to the vertex. If A is close to 0 but still negative, maybe it's -1/16 like I mentioned before, that's going to make the parabola fatter, but again, still open down, so it'll look like this, and it's going to move the focus farther away from the vertex, but in a downward direction. It's no longer getting closer or farther away by going up, it's getting farther away by going down. And then finally, our directrix is pretty similar to our focus. Remember, if we're just going to look at this standard parabola right here with a vertex right here, and our focus is right here. Well, if the focus is 1 over 4A units, in this case above our vertex, by the definition of a parabola, the directrix needs to be 1 over 4A units below the parabola, because they are equidistant from this vertex. Okay, this vertex is exactly in the middle of the focus and the directrix. So if it's 1 over 4A units, if this distance right here is 1 over 4A, then this distance here also needs to be 1 over 4A, because it's in the middle of those two things. Okay, so our directrix is pretty similar to the focus, But remember, the directrix is a line, so we don't write it as a point, we write it as an equation of a line. Since it is a horizontal line, it's going to start with y equals. Y equals means the line is horizontal, so it looks like this. Okay, so we've got the equation y equals still k. We're talking about the y value of our vertex, which is k. Okay, so if we start with the equation y equals k, that would be this horizontal line right there. But we've got to move it down away from this vertex. Okay, and how far away are we moving it down? Well, we're moving it down 1 over 4a units again, where again, that a value is the a value that we started with up here. Okay, and just like before, if the parabola is reflected over the x-axis and opens down, then the a value would have to be negative, which would make this entire thing negative, which would then make it k plus whatever that 1 over 4a is, and move the directrix above our vertex, and the parabola is opening downward. Okay? So those are the key points when we've got a vertical parabola. But this might be new. We can also have a horizontal parabola. So we're going to talk about that next. Okay? If we have a horizontal parabola, the idea is pretty similar, okay? But we've got a few things that are different, okay? So I guess I'll move back over here so we can see what these rows are talking about. The equation for a horizontal parabola is almost the same as a vertical, but we're starting with x equals now. Okay, so we've got x equals, still a here at the front of the parentheses, but now we've got y minus k in parentheses squared plus h. Okay, so a horizontal parabola would look like this, or it might look like this. Okay, it could open left or right, just like a vertical parabola can open up or down. A horizontal parabola can open left or right. All right, now you might notice this is not a function. This does not pass the vertical line test we have for functions, which is why it starts with x equals. If you were to graph this, we have 2 points right here for this x value, so it is not a function. It does not pass the vertical line test, which is why we're writing it as x equals. Okay? And so we've got x and y kind of switched in this equation, but you might also notice that h and k have switched as well. K is now inside the parentheses, h is outside the parentheses. And that's because k, if we look at the equation for a vertical parabola, k is outside, it's impacting the graph in terms of up or down. It's moving the graph up or down. But the coordinate that's moving your graph up or down is the y coordinate. So k needs to be inside the parentheses with that y coordinate. Just like how h moves it left or right, it's inside the parentheses with the x value, which moves your parabola left or right. So since x is on the left side of the equal sign out here, h, which moves our parabola left or right, is outside the parentheses here, impacting the output of our function x. K is inside the parentheses, impacting the input now, y, which is also inside the parentheses. So x and y have switched, h and k have switched, a is still out in front of that parentheses, and it still makes the parabola fatter or skinnier, depending on if it's greater than 1 or if it's in between 0 and 1. Okay? Now, the standard parabola, this one right here, if a is positive, it's going to open to the right. Okay, so if a is positive, it opens to the right. If a is negative, then it opens to the left and kind of looks like this. Okay, so just like how a in the vertical parabola reflects it over the x-axis, a reflects it over the y-axis now and will open it to the left. Okay, your vertex is still at hk, but now we're not taking the opposite kind of what h is like we did with a vertical parabola, because h is outside the parentheses. Whatever we're adding or subtracting on at the end, that's going to be the x-coordinate of your vertex. K is now the point inside the parentheses that's being subtracted from y. So if it were, say, y minus 2 in parentheses squared, then your y-coordinate of your vertex would be positive 2. If it were y plus 2, well, that's like y minus negative 2. So then it would be negative 2 for the y-coordinate of your vertex. Your focus, now if we look at a horizontal parabola like this, okay, here is your vertex at HK still. Here is your focus. Okay, you'll notice that the focus now has the same height as your vertex. Okay, it's not any higher or lower. It's the same height, which means it has the same y value. So the y value of your focus is not going to change. Just like the x-coordinate here didn't change in a vertical parabola, in a horizontal parabola, the y value is not going to change. It's now the x value of this focus that's going to change because it's a little farther to the right in a parabola that's opening to the right. So we're going to need to add to the x-coordinate of our vertex. So the x-coordinate of our vertex is h, but we need to add still 1 over 4a units because this vertex is moving to the right. Okay? Again, if the parabola were skinnier, then the focus would be getting closer and closer to the vertex. If the parabola is fatter, then the focus is going to get farther and farther away from the vertex. Okay, and that distance is just 1 over 4a, where a is still the value in front of the parentheses there. And our directrix is going to be a vertical line, okay, because this is a horizontal parabola. Our directrix is going to be a vertical line. The parabola will never intersect the directrix, okay? So if our directrix were a horizontal line, something like this, at some point our parabola would intersect this directrix, which doesn't make any sense with the definition of a parabola because all the points should be equidistant from the focus and the directrix. But if our directrix intersects that parabola at some point, well, the distance right there between our parabola and the directrix is 0. But it's obviously not 0 to get to that focus, so that would not make sense in our definition of a parabola. So in a horizontal parabola, our directrix goes straight up and down like that. When we have a vertical line that starts x equals, and the x value of our vertex is h, so it's going to be x equals h. But again, we're not at h, we're a little bit away from h. And that little bit away we are is 1 over 4a units. Okay, same a as before, and just like in a vertical parabola, we're subtracting that 1 over 4a because in the standard parabola opening to the right, we are to the left of it, so we would be subtracting from that h value. Okay, whoops, I highlighted this k the wrong color. And just like I mentioned before, if a is negative, then that's going to reflect everything. And your parabola is now going to open to the left. Your vertex is still right here. It's now at the rightmost point instead of the leftmost point. But your focus is going to be to the left of that vertex. But that's okay because a is negative. That would make this a minus sign because this whole thing is going to be a negative value. And if a is negative, it would turn this into a plus because this is going to be negative. So it would make your directrix to the right of your parabola. Okay, so when a is negative, it moves the focus to the left now, and it moves the directrix to the right. So now that we know all the properties of a parabola and how to find them when it's written in vertex form, it would be advantageous for us to know how to get the parabola in vertex form if it's not already in it. Okay, so in this example here, it's telling us to write the parabola in vertex form, and it's given to us in standard form. Remember, standard form is y equals ax squared plus bx plus c, but we're looking to get it in vertex form, which is y equals a times x minus h squared plus k, assuming this is a vertical parabola, which it is. Okay, so in order to get this parabola in standard form, in vertex form from standard form, we're going to have to complete the square. Okay, but in order to complete the square, we ideally would like a 1 coefficient in front of this x squared, not a negative 4. Okay, but conveniently enough, we're able to actually factor a negative 4 out of these first two terms, minus 4x squared plus 16x, and make this much easier. It's okay that we can't factor it out of this minus 14, the c value on the end. We actually don't need to. All we need to do is factor a negative 4 out of those first two terms. So if we do that, we have y equals negative 4, and then we get just x squared, which is great. If we factor a negative 4 out of this 16x, we have minus 4x, and we still have the minus 14 here on the end. Okay? So now that we've done that, we're able to complete the square inside the parentheses here. Remember, when we're completing the square, we need to look at this linear term right here, that minus 4x, and we need to add and subtract this term divided by 2 squared. Okay? So we need to add and subtract negative 4 divided by 2 squared. Okay, so negative 4 divided by 2 is negative 2. Negative 2 squared gives us positive 4. Okay, so we need to add and subtract positive 4, or add and subtract 4, in order to be able to complete the square. Okay, we have to add and subtract because we can't just be adding things to our equation willy-nilly because it would make the value of this thing different. Okay, it's whatever we're doing to our equation, we need to make sure that it's exactly the same, it's equivalent to what we're starting with. If we just add 4, that's not going to be the case. Okay, so we're now going to have y equals negative 4 times parentheses x squared minus 4x plus 4. Okay, we're doing this because now this right here is a perfect square trinomial, and we're able to factor this and make it look like this, x minus h squared, or x plus or minus something in parentheses squared. Okay, so we're going to go ahead and close off our parentheses right there, but we're not done. We added 4 here. We also need to subtract 4, but we're not just adding 4 inside the parentheses. We're adding 4 inside a parentheses that's being multiplied by negative 4. So we can't just subtract 4. We need to subtract 4 times that negative 4 out in front. Okay? So we're actually going to subtract 4 times negative 4 in parentheses. And we can't forget about this minus 14 here on the end. Okay, so what did we do? We had x squared minus 4x in parentheses. We then decided that we're going to add and subtract 4 because it makes this part right here very nice. It makes it factorable. But we can't just add 4. We also have to subtract that 4 outside the parentheses. So that's what we did. Okay, and then we also have to bring down this minus 14 here. So our next step is let's factor this x squared minus 4x plus 4. Like I said, that's a perfect square trinomial. You could factor this like you factor any other quadratic, okay, using the diamond or factor by grouping or whatever method you use to factor quadratics. But the shortcut is this is just going to be parentheses x plus whatever this term is divided by 2. Okay, that middle linear term, if you divide it by 2, that's what's going to come after x. Okay, so negative 4 divided by 2 is negative 2. We're not going to square it. We just divide by 2. So x minus 2 in parentheses squared. The reason we're able to do that is because these two things are equivalent. If you off on the side multiplied x minus 2 by x minus 2 and multiplied these two binomials, whatever way you multiply binomials, you would get x squared minus 2x plus 4. And then if you combine those two in the middle, you have x squared minus 4x plus 4. So these two things that I underlined are both equivalent. Okay, this is just the factored form of it, and we're doing that to be able to get it in vertex form. So what I like to describe what we're doing is, it's kind of like we're starting with a piece of Play-Doh up here, okay? And this piece of Play-Doh, is not the way we want it to look. Maybe we want to build something out of this Play-Doh. So what we're going to do is we're not going to add Play-Doh or take Play-Doh away. We're just going to manipulate and roll and fold the Play-Doh to get it to look like something that we want it to look like. Okay, so we've completed the square. We rewrote x squared minus 4x plus 4 as x minus 2 squared. And now our last job is to combine our like terms right here. Minus 4 times negative 4 minus 14. Well, negative 4 times negative 4 is positive 16. So we have plus 16, and we still have that minus 14. What is 16 minus 14? Well, that's just 2. So we have a plus 2 here on the end. Now, our parabola is in vertex form. We've got y equals negative 4 parentheses x minus 2 squared plus 2. And now it's a lot easier to find our vertex, focus, and directrix. We're not going to do that. I'll go ahead and find the vertex. Okay, since it's in vertex form, we can immediately say that our vertex is at h, which is positive 2, since it's x minus 2 in parentheses, h is positive 2, and k is also positive 2. Okay, so we can say our vertex is at 2, 2. We could also quickly find our focus and directrix if we needed to, but in this one, all we had to do was write it in vertex form. So the next problem type we've got here is they give us the vertex of a parabola and either the focus or the directrix, and we need to determine the direction of opening. So we need to decide, is this parabola opening up? Is it opening down? Is it opening right? Or is it opening left? Okay, which one of these does it look like? Okay, and in my opinion, the easiest way to do this is just do a very, very rough sketch of your vertex and your focus and or directrix. Okay, so if we have a vertex at 4, 7, that means if we have our x and y axes like this, we're going right 4 and up 7. We don't need to draw the tick marks and actually figure out exactly where it's at. Again, we just need a very rough sketch. So if we're going right 4 and up 7, it's somewhere over here. It doesn't have to be perfect. We just need a rough idea of where it's at. If the focus is at 4, 16, where is that at relative to the vertex? Okay, the focus is either going to be here, 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 or here. Either directly above or below, or directly to the left or the right. Okay, so it's at one of these 4 spots. It wouldn't be, it wouldn't be here, or over here. Okay, because then our parabola wouldn't open straight up, straight down, straight to the right, or straight to the left. It would be like a slanted parabola, and we're not going to deal with those. Okay, so if our focus is at 4, 16, well, that means we're going to the right the exact same amount as our vertex. Okay, so it's either going to be directly above or directly below our vertex. And if the y coordinate is 16, well, if we go up 16, here's 7, and then we're going to go up even more. So our focus would be somewhere up here. Okay, again, it doesn't have to be exact. I know that if this distance right here is 7, then this is probably not 16, but that's okay. All we need to know is that our focus is directly above our vertex, because that's enough to determine the direction of opening for this parabola. Okay, because remember, the focus is always inside the parabola. We can quickly say that this parabola is going to open up. So our answer would be up. The parabola is opening up. This next one over here, we've got a vertex at -3, -9. So if that's our x and y axes, we're going left 3, down 9. So our vertex is somewhere over here. Our focus is at -8, -9. Okay, so you'll notice that now we're going farther to the left than our vertex. Okay, our focus has an x-coordinate of -8. The vertex has an x-coordinate of -3. We're going to the left more to get to our focus, but we're going the same amount down. We're going down 9 for both our focus and our directrix. So they've got the same y-coordinate now, but different x-coordinates. Our focus is going left more, down the same amount, so it's somewhere over here relative to our vertex. Because of that, again, remember the focus is always inside the parabola. our parabola looks something like this, and it's opening left. So that would be your answer. It's opening to the left. Our next example here, we've got a vertex at 8, -2, a directrix at y equals -1. So here are our axes. Our vertex at 8, -2 is somewhere over here. Now they give us the directrix. Remember, the directrix is a line. It's not just a point. Okay? If our directrix is the line y equals -1, okay, the line y equals is going to be a horizontal line. Okay, it's kind of confusing because, you know, the x-axis is the horizontal line, but the line y equals something is a horizontal line. So if the line is y equals -1, we're only going down -1, which is not quite as far as we went down for the vertex. The vertex, we went down -2. The directrix, we're only going down -1. So our directrix is going to be right here. Okay, pretty close to the vertex, but it is still above our vertex. And remember, I said that the parabola is always opening away from the vertex. It's never going to intersect, opening away from your directrix. It's never going to intersect your directrix. Because of that, this parabola is going to open down, and that would be our answer, down. Okay. And finally, our last one here, we've got a vertex at -4, 10. So we're going left 4, up 10. That puts us somewhere over here. And then our directrix is at x equals -6. The line x equals is a vertical line. Okay, again, kind of confusing because the y-axis is the vertical axis, but the line x equals is a vertical line. If it's x equals -6, well, the x-coordinate of our vertex is -4. X equals -6 means we're going even farther left than our vertex, which puts us somewhere over here. So this would be the line of our directrix. Which way is this parabola going to open? It's opening to the right. Okay? Now, you might think that this parabola could open down. You might say, oh, it can never intersect the directrix, it's going to look like this. But remember, the domain of a vertical parabola is all real numbers. So this parabola is, although it may not look like it, it is slowly going left forever and ever. So at some point, this parabola would intersect your directrix, which is no good. Okay, so because of that, our parabola has to open to the right. So now let's try some problems where they give us two pieces about the graph of the parabola, and we have to write the entire equation of this parabola. Okay, so here they give us the vertex is at -8, -4, and the focus is at -8, -17/4. Okay, so I think a good idea is to first figure out which way does this parabola open? Is it horizontal or is it vertical? And is it opening up or down? Okay, so in this parabola, again, just like we did on the previous example, let's do a rough sketch and figure out which way this opens. So here's our x and y axes. -8, -4 is somewhere down here. Okay, now our focus is at -8, -17/4. Okay, so the x coordinate is the same as our vertex. So it's going the same distance left as our vertex. So the focus is either going to be here or here. We need to decide, is this focus, is the y value more than -4 or is it less than -4? Okay, if you're struggling to figure out is -17/4 more or less than -4, you could certainly type that in your calculator, -17 divided by 4, and quickly get an answer. But -17/4 as a decimal is -4.25, which is a little bit less than -4, which means our focus is going to be below our vertex. Okay, let me redraw that y-axis. So, or x-axis, our focus is going to be right here, which means the the parabola is going to open down. So now we need to write the vertex form of the parabola. Remember, vertex form is y equals a times x minus h squared plus k. Since this is a vertical parabola, it's opening down, we know this is the vertex form. Okay? And two of these things that we need to find are really easy to find. We know what h is. H is just the x-coordinate of our vertex. We know what k is. K is just the y-coordinate of our vertex. Okay? So we now have y equals a times x minus h. H is negative 8, so x minus negative 8 would actually give us x plus 8 squared, plus k. If k is negative 4, that's going to be minus 4. So we have y equals a times x plus 8 minus 4. So now all we have to find is a. Okay, x and y are going to stay x and y because that's the general form of a parabola. Y equals ax minus h plus k. Just like a line is y equals mx plus b, we leave x and y as x and y. That's our input and our output. We're not going to substitute anything in for those in our answer. All we need to find are a, h, and k. And remember, a is used to find the coordinate of our focus and or our directrix. Okay, our focus is 1 over 4a units away from the vertex. Okay, our focus is 1 over 4a units away from the vertex, specifically above. Okay, since our focus is below the vertex, technically it's below, but remember, a is going to be negative in this case, so we're going to say that the distance between our vertex and our focus is just equal to 1 over 4a. Okay, the distance between our vertex and our focus is 1 over 4a. And what is the distance between our vertex and our focus? Okay, we don't have to use, I suppose you could use the distance formula, but we don't need to do that. Okay, the distance between our vertex and our focus, they have the same x-coordinate. They're both negative 8. So we don't have to worry about that. We really just need to worry about the distance between negative 4 and negative 17 over 4. What is the distance between those two things? Well, that distance is negative 0.25, or negative 1/4. Okay, so the distance between our vertex and our focus. Let me write that. The distance between the vertex and the focus is negative 1 over 4. Okay, which means that negative 1 over 4 is equal to 1 over 4a. Negative 1 over 4 is equal to 1 over 4a, because the distance between your vertex and your focus, according to this table right here, is just positive 1 over 4a. Okay, so we say negative 1 over 4 is equal to 1 over 4a, and we can quickly realize that in order to make this equation true, what does a need to be equal to? Well, a has to be equal to negative 1. Whoops. So a is equal to negative 1. Okay, if you wanted to solve this equation, you could, but it's pretty obvious to see that we need to make a negative 1 to make these two things equal. So then the equation of our parabola in vertex form is y equals a. And what is a? Well, we just said a was negative 1. So y equals negative 1 times x minus h. H is negative 8, so x plus 8 squared plus k, where k is negative 4, so minus 4. Okay, this is the vertex form of our parabola with a vertex at negative 8, negative 4, and a focus at negative 8, negative 17 over 4. Now, one other way you could find the a value is we could kind of set up an equation. Remember, we said the focus has an x-coordinate of k plus 1 over 4a. And we know what k is. We also know what the y-coordinate of our focus is. So we could say that the y-coordinate of our focus, negative 17 over 4, I'll do this over here. We could say negative 17 over 4, the y-coordinate of our focus, is equal to k plus 1 over 4a. But what is k? K is negative 4, so we could say it's equal to negative 4 plus 1 over 4a. And then we just need to solve for a. Okay, so our first job would be to add 4 to both sides to get 1 over 4a by itself. Negative 17 over 4 plus 1 over 4 is negative 1/4 equals 1 over 4a. And then we're exactly where we started over here. Okay, so this is just if you're struggling to find the distance between your vertex and your focus, this is something you could write if you would rather solve an equation to find that distance and then solve for your a value. Okay, but again, it's just the distance between your vertex and your focus. The distance between those two things is equal to 1 over 4a. This next example here is pretty similar to the last one, in where we're given two features of the graph of the parabola, and we need to write the equation in vertex form, okay? But instead, this time, instead of the focus, we are now given the directrix, okay? But we still have the vertex. Our vertex is at 2, negative 10, all right? So we know those are going to be h and k. But before we start writing anything, let's go ahead and figure out which way this parabola is going to open. All right, so here are the x and y axes. Well, let's move this over a bit. Here are the x and y axes, okay? And 2, negative 10 is somewhere over here. Now, our directrix is the line x equals 25 over 16. Okay, so if it's the line x equals, that means it is a vertical line, so it's going straight up and down. And 25 over 16 is not quite to this x equals 2, okay? 25 over 16, if you type that in your calculator, it's going to be between 1 and 2, a little more than 1.5. So it's actually going to be right here. So this is our directrix, which means this parabola is going to open to the right. Okay, but it is a horizontal parabola, which means the equation of this is not going to start with y equals. We've got to use our horizontal parabola equation. So it's x equals a times parentheses y minus k squared plus h. And again, we already know h. It's the x-coordinate of our vertex 2. We know k is the y-coordinate of our vertex negative 10. And we know the directrix is 25 over 6. So all we need to do now is find a. Okay, if we can find a, then we have enough to write the equation of this parabola. And remember, a can be found by using our directrix, because the distance between your directrix and your vertex is just negative 1 over 4a units. Okay, your directrix is negative 1 over 4a units away from the vertex. Since this is a horizontal parabola, we're going to be comparing the x-coordinate of our vertex to the equation of the directrix, and the distance between those two is that negative 1 over 4a. All right, so what is the distance between 2, the x-coordinate of our vertex, and 25 over 16? Okay, what's the distance between 2 and 25 over 16? Well, 2 is 32 over 16. All right, so the x-coordinate of our vertex is 32 over 16. Okay, so how far away is 32 over 16 from 25 over 16? Well, the directrix is negative 7 over 16 units away from our vertex. So negative 7 over 16 is equal to negative 1 over 4a. Okay, negative 7 over 16 is the distance between our vertex and the directrix. We're going from the vertex to the directrix. That's why it's a negative 7 over 16. And remember, that's always equal to the distance between the vertex and your focus is positive 1 over 4a. The distance between your vertex and your directrix is negative 1 over 4a. So now all we need to do from here is solve this proportion. So we can go ahead and cross multiply. Negative 7 times 4a is negative 28a. Negative 1 times 16 is just negative 16. If we divide both sides by negative 28, then we would get a is equal to both of these two things can be divided by 4, so it would be 4 over 7. So a is 4 over 7. And again, now we can write the equation of our parabola. Once we've got a, h, and k, we can write our equation. So the equation of this parabola is going to be x equals, remember this is a horizontal parabola, so we start with x equals 4 over 7 is the a value, times parentheses, y minus k. If k is negative 10, that's going to be y plus 10 in parentheses squared, plus h, which is 2, so plus 2. Last one here where we're going to be writing the equation of a parabola given some features of its graph. In this case, they give us the focus and the directrix. Okay, so we immediately don't know what the vertex is. Okay, so this one, again, let's go ahead and draw a rough sketch and see if we can figure out if this parabola is horizontal or vertical. So here are the x and y axes. Our focus is negative 2, negative 81 over 16. We'll say that's somewhere over here. Okay, negative 81 over 16 is just a little bit past negative 5. Okay, and then our directrix is at y equals, so that is going to be a horizontal line, y equals negative 79 over 16. So negative 79 over 16 is not quite as far down as negative 81 over 16, so that's going to be above our focus. So our directrix is something like this, which means our parabola is opening down like this. Okay? And since we know this parabola is opening down, then we know that our vertex of our parabola, this little blue dot I made right here, has the same x-coordinate as our focus. Since this is opening down, our vertex and our focus are going to be the same distance left or right from the origin. Okay? The only difference in their coordinates is going to be the y value. So we can say that h is equal to negative 2, the same as the x-coordinate of our focus. Now, k is not the same as the y-coordinate of our focus. In order to find k, we need to utilize the fact that the vertex, remember, is equidistant from the focus and the directrix, or every point on a parabola is the same distance from the focus and the directrix. So essentially, we need to find what number is in the middle of negative 81 over 16 and negative 79 over 16. We're comparing the y equals value of our directrix to the y coordinate of our focus. And this one's pretty obvious to see, but if you need to, you can always add those two values together. Negative 81 over 16 plus negative 79 over 16. And divide it by 2, kind of like finding the midpoint, but the directrix isn't necessarily a point. It's a line, but we're finding the point on the line, or we're using the point on the line that also has an x-coordinate of negative 2. Okay, so if you want to do that, you can, but like I said, this one's a little more obvious to see. The point halfway between the focus and the directrix is negative 80 over 16, okay? And negative 80 over 16 is negative 5. So we'll say k is equal to negative 80 over 16, which simplifies to just negative 5. Okay, so that is k. So now all we need to do again is find the a value. Okay, we know this is a vertical parabola, so our equation is going to be y equals a times x minus h squared plus plus 5. Well, I guess minus 5, but I'm going to write plus k here for now. So y equals a times x minus h squared plus k. So all we need to do is find a. And just like the previous two examples, we're going to do that by comparing the distance between our vertex, which is at -2, -5, and our focus, or the distance between our vertex and our directrix. You have a choice in this one. You could use either one. Let's go ahead and use the focus, though. Okay, so the x-coordinates of our focus and our vertex are the same. So we're not going to compare those. We're going to compare the distance between the y-coordinate of our focus and the y-coordinate of our directrix. Okay, so what are we doing to get from -80/16 and to -81/16? Okay, the y-coordinate of our vertex and the y-coordinate of our focus. And you can see to get from -80/16 to -81/16, we're going down 1/16. Okay, we're going down 1/16 to get from -80 to -81/16. And that 1/16, that distance from our vertex to our focus, is equal to, remember, with the focus, it's positive 1/4a. Okay, now if we want to solve this, you might be able to solve this one in your head, but we can go ahead and cross multiply, and we have -4a equals 16. And then if we divide by -4, we get a is equal to -4. Okay, and that's enough to write the equation of this parabola. It's going to be y is equal to -4 times parentheses x minus h. If h is -2, that's going to be plus 2 squared plus k. K is -5, so we've got a -5 there on the end. So remember, find h and k from your vertex. Either it'll be given to you, or you may have to find the point right in the middle of your vertex, or your focus and your directrix. And then once you know the coordinates of your vertex, all you need to do is find a by utilizing the fact that your vertex is 1/4a units away from the focus and -1/4a units away from the directrix. Last example here in this video, we're kind of shifting gears from writing the equation given some properties of the graph to matching an equation to its graph. Okay, so we've got this equation here, y is equal to 2 times parentheses x plus 1 squared minus 1. Okay, so the first thing we should do in examples like this is figure out, is this a horizontal or a vertical parabola? You can probably guess from the examples, or the options, that this is going to be vertical, but we can also say it's vertical because it's y equals and x is inside the function, okay? So this is a vertical parabola. Sometimes you'll be given options where some of these are vertical and some are horizontal, okay? So you'll need to decipher which way this parabola is oriented. All right, so now let's figure out, is this parabola opening up or is it opening down? We figure that out by looking at the a value. If a is +2, then that means this parabola is not being reflected over the x-axis and it's going to open up. So we can eliminate this one and we can eliminate this one. Okay, our last step to match it to a graph is, let's find the vertex of this parabola by looking at h and k and matching that to one of these last two options, okay? So if we've got x plus 1 squared here in parentheses, then that means our vertex is going to be at -1 for the x-coordinate, the opposite of that number in there. And the y-coordinate is also going to be -1 because we've got a -1 here on the end. So of these two options, the only one with a vertex at -1, -1 is this one right here, D. So that would be your answer. A has a vertex at the origin, which is not what we want. So thank you for watching. I hope this helped clear up some misconceptions you might have about parabolas, and how to write their equations or match it to a graph or put it in vertex form. Have a great day.